there are a few more important definitions that we need to cover. First thing we want to talk about is quartiles. Now, if you remember, when we looked at percentiles, there were 3 percentiles that were so important that I circled them and said they would be coming back, and now they're back. So this is the first quartile, the second quartile, and the third quartile, because the first quartile would have 25% below it. The second quartile would have 50% below, right? The third quartile would have 75% below. So that's this piece up here. Now, the second quartile you've already learned as another place called the median. So P50 is Q2, which is the median. It's the middle value, right? So it's the 50th percentile, which is P50, or the second quartile, which is Q2. So both of those ways of writing it, P50 and Q2 and the median, you're expected to know. All right, what about the first quartile? Well, the first quartile is P25, which is the 25th percentile. P25, which is also Q1. It has 25% below, right? Oh, which I might have mentioned right here. This is 25% below right here. That's the first section because this is the minimum right here, the min. And over here is the max. And there's 25% in this piece, right? It's called a whisker. We'll learn more about this graph in the next section. And then you have 25% here in this box. 25 and 25 makes 50. So 50% is below this line. And then you have another 25% right here and another 25% right here. And then this line over here on the right is the 75th percentile, or P75, which is right here. It's the third quartile. So those three, actually let me circle them. The minimum, Q1, right? Q2, i.e. the median, Q3, and the max. Those 5 numbers are called the 5-number summary. Now, they're a really great way of knowing what the lowest value is, what the highest value is, and where the middle sections are. It's a great way of measuring center with the median, spread with the Q1 and Q3, and the range with the min to the max. So it's an excellent way of doing this. As a matter of fact, when I give exams back to students, I usually don't give them mean and standard deviation because usually the data set is skewed. Instead, what I give them is the 5-number summary. So that way they can kind of tell where they lied in relation to this group. So 25% of scores are below Q1, 50% of scores are below the median, 75% of scores are below Q3. And of course, the max is the highest and the min is the lowest. That makes the 5-number summary, right? It's 5 numbers that represent a data set extremely well. Just as a little heads up and a warning for you, Q1 and Q3 are found differently for different books and programs, and we are going to use the values from StatCrunch because that is the software we use for our course. So those are the values you are expected to find. So Q1 and Q3 can be found slightly differently depending on which method you're going to use, because there are different methods. All right, now speaking of Q1 and Q3, there's another definition called the IQR. The interquartile range is this distance from the Q1 to the Q3. It's how far apart they were. So it's the width of the box in a box plot, which is what this is called, by the way. This is called a box and whisker plot or a box plot. We'll again learn about it more in the next section. Okay, so there's a formula right there. IQR is Q3 minus Q1. Very important. And it's the width of the box in a box plot. So if you want to label that, IQR is this distance right here. It's Q3 minus Q1. Now, the advantage to IQR is that it resists outliers, just like the median does. The quartiles in general resist the outliers, and so does the IQR, therefore. And that makes it so that it's a better measure of spread for skewed data. So if your data set is skewed, it resists that skew. So it's the better measure of spread, right? Because it tells you a different way of thinking about how spread out your data is besides just a standard deviation, right? Standard deviation works great as long as your data set is symmetrical. But once your data set is skewed, you're better off with the IQR for your measure of spread. And last but not least, there is an official way to check for outliers. I know we talked about unusual z-scores. Unusual z-scores are not outliers per se, right? Outliers are a bit more fine-tuned than that. So this is unusual, true, but it may or may not be an outlier, right? So if you want to make a note to yourself, back several pages, right? Unusual could be an outlier, so it may or may not be an outlier. Outliers are more specific things. So it may not or it may, depends, right? A lot of times they are, but not always, right? Whereas over here, sorry, this is how we truly determine outliers. Outliers, you have to find the fences. There are these formulas right here. There's a lower fence and an upper fence. Anything that is outside of those fences, anything that is below the lower fence or above the upper fence is unusual. So this is the regular zone. Right? So let me just make a note here. This is the official method for finding outliers. It's not the z-scores. Right? It's not the z is greater than 2. Or I'll just say not z-scores. Right? Which I actually just wrote below. If you look right here. That's what I'm writing right here, right? Unusual values are not necessarily outliers.